I'm Reza Niamanesh, and I'm going to present my solution to problem number 3, siren. The problem states if we direct an airflow into a rotating disk with holes, a sound may be heard. Explain this phenomenon and investigate how the sound characteristics depend on relevant parameter. And a recording of the sound that the problem is referring to is this. And here is an overview, and let's start with the initial observation. So when we direct airflow through the hole on the disk, we hear a sound which is a non-periodic wave, and the change of amplitude by time are shown on this chart on the disk with 12 holes on it and 15.7 revolution per second. The reason that a sound heard in this experiment and phenomenon is the created pressure difference. In the other word, we could say spinning the disk with holes on it is creating frequency that we desire. It lets the air flow through it and blocks it periodically. So by investigating this pressure difference, we realize that the hole on the disk itself, this pressure difference is worst, and what explained in this is the Bernoulli principles. This chart shows us the pressure on the rotating disc, which reminds us of a speaker, and so we decide to compare the siren disc with the other electrical audio devices. As you can see, this video shows us the speaker device, which by slow motioning twice, we can see how the speaker compresses the air around it, and here is a chart of the pressure by time. According to the air particle compression schematic, we understand that these two sounds have similar patterns. And so we can say that they have the same characteristics as well. Here I studied the sound characteristics. One of the main parameters is frequency, which we have a theory for that. States that the frequency equals to number of the holes around the center from same distance from center, and the next main parameter is intensity, which we will deal with it in the future slides, and the last one is duration, which is in our situation is not important because all of our experiments is the same duration and it's continuously. To analyze the sound that we hear, we need something that can divide the sound into individually frequency components, so we could recognize the siren frequency and analyze it. What we are looking for is Fourier series. By using the Fourier series, we can define any function as a sum of a series of sine and cosine function, and by writing these, we can recognize the frequency of the siren through intensity. To understand how the Fourier can define functions, observe that its curve function is described by Fourier in this video. The higher its amount, the closer to the definition is the desired function. As I said, the sound intensity is one of the main parameters, which is defined as follows, as you can observe, and the related parameter are defined as these. Rho equals to these, and these are the relevant parameters of it, and this is the C, or speed of the sound, that we observe, and here, and there is the exact formula of it, and this is the frequency that it's so popular, and we know that. And the second formula that originated from the first one is the sound intensity by pressure difference, which we use with the Bell balance or decibel. Our first setup that we had was too basic, so we improved it by adding a pop filter, the pressure gauge, and then we add air compressor to stabilize it, and also to have tried the experiments with the air compressor. And finally our last setup was um, completed by a platform with shock absorbers and fixed distance of the microphone, and a fixed distance between the microphone and the airflow holder, and it's overall of them. One of the problem we come up, our problem that we had was choosing the airflow option in our experiment. So first we decided to use blowing, that's so simple, and next we decided to use balloon, and the last one we decided to use air compressor. And so for ordering them, we decided to create a of feature of them. As you can observe, the controlling measurement and stability. As you can observe, the compressor is the best of them, is the best of all, and why we don't use it is because of the decreasement and the decreasing pressure of it. By experimenting these 5 times, we found that between the time period of 100 to 300 seconds, the pressure approximately is constant, and so that we in this time we could test our experiments, as you can observe in this period of time. The noise that existed while recording the sound was a problematic because it made our analysis incorrectly, and so by using Adobe Audition and Audacity, we made the siren's frequency bold and reduce the noise by Adobe Audition and Audacity. And this is after being the noise sound. And for better understanding, let's compare these two charts, before and after chart, and these chart are frequency chart by time. And as you can observe, the highlighted area of other frequency um, being reduced, and the chart shows the frequency by time and that I set, and it's got from Adobe Audition. Let's move on to our experiments, and the first parameter that we experimented was a different RPS, or revolution per second, which was we used 4 different ones on in our experiments. The sound that we are hearing it is different sound of different frequency of discs from 3.9 to 15.7 revolution per second. That's we write them frequency in the near of them. And the interesting point that reminds to our mind is if we divide the frequency that we hear by revolution per second, as you can see, the number that get it is approximately equal to the number of the holes on the disk. And so if we repeat the same experiment with 6 other revolution per second and 5 other disks with 5 different whole numbers, we arrive at the same conclusion. As you can observe the charts and the real slope on right side, and we count them with pendulum counter. So we can say that the frequency that's produced by the siren is equal to the number of the holes that are from the same distance between from center of the disk multiplied by revolution per second. The rest of the parameters is affect the RPS and change the frequency. And by changing the frequency, we could change the intensity and In the future slide we will deal with it. Next experiment was different pressure, and which according to Bernoulli we could say they covered experiment with different airflow velocity, which we did by using the compressor. As it observed in this chart, there is a noticeable differences between the number of extracted from theory and the number that extract from the experiments. This goes back to the pressure drop that we pointed out in the part that we choose our airflow, and I have to mention that in the all of our case I naught is equals to 10 power by 7, because our application base intensity is also equals to 10 power by 7. According to our experiment, the frequency is constant and only the sound intensity has changed, which we can conclude with these formula. Next parameter is the material of the disc, which we can experiment with plywood and CD. And we observed the frequency and the sound intensity in both cases is approximately equal. We expect the math change by changing the material, and we expect by changing the material the omega or RP is going to change, and changing our frequency, but it's don't change because in this case the thickness and the height and the other parameter are equal to each other because of standard of disk. So we could say in this case with same thickness and size there is no significant differences. The next parameter that we investigate is the thickness of the disk. As you can observe, these are four different thickness that we had, and by increasing thickness we could say we increase our mass and decrease our RPM revolution per second. So we could say by these formula that we prove it in the past slide, we could say the frequency is going to decrease, and by decreasing the frequency from these formula we could say intensity is also going to decrease. And this is our experiment, and our experimental theory is almost proportion. And this plot shows the result of our experiment for four thicknesses: 0.2, 0.3, 0.5, and 0.4 centimeter. And by plotting all of them together, we realized that by increasing the thickness of the disk, the frequency and sound intensity going to decrease. And now we compare our experiment result with our theory, and we could find that they match are correct. The next parameter that we investigate is the angle of the drill bit, which is indeed the experiment with 90-degree and angle with oblique angle. And we found that if we experiment it with angle, then a vertical and oblique angle, just intensity going to decrease and frequency just stay constant, as you can observe. And the last parameter that we experience is different size of the hole on the disk, and as it observed in this case, our first drill bit is 1.9 millimeter, as you can observe, and this plot is for 2.2 millimeter drill bit, which you can see the only sound intensity increased, and this is for third drill bit. As you can observe, sound intensity just increase, and the biggest drill bit that we have 5.4 millimeter, also we only see the change of intensity. And by combining our four thicknesses plot, we realize that increasing the diameter of the holes, sound intensity increase, but the frequency stay constant. So here we create a melody by directing the airflow to different row of holes, and now you can hear it. Then I show you the pattern that we just move our airflow, and this is the pattern that we moved our airflow. This is the summary of all experiments that we did, which the revolution per second, by increasing it, the frequency going to increase, and by increase our pressure, our different pressure of airflow and velocity, or airflow velocity, intensity just going to increase, and by changing the material of this, we could neglect it, and by increase our thickness of disk, the frequency going to decrease, and the size of the hole, by increasing them, the intensity going to increase, and the number of holes, by increasing them, the frequency going to increase. To conclude my presentation, I start with the phenomena explanation, directing our airflow, non-periodic wave, and next we talk about the sound characteristics, intensity, frequency, then the theory of them, and the speaker frequency and the same sound characteristics, and the next was Fourier, how we write Fourier and define the function by Fourier, and quantitative theory, as you can see, but intensity theory and the frequency theory that we tested with our experiment, and our experiment that just we experienced with the thickness, the angle of drill bit, the different RPS and number of holes, and the last was results that compare all of them, and these are my references, as you can observe, and thank you for your attention.